Hi guys, today we're going to be looking at Cambridge IGCSE Additional Mathematics, October-November 2022, Paper 1-3. So we're going to start now. First question is about graph sketching. So we need to sketch the graph of this equation. So first thing, we need to find the amplitude. So amplitude can be given by this number here, which is 4. Second, we need to find for the period, and period can be found by 2 pi over the number over here, which is 3. So period is 2 pi over 3. And lastly, we need to find the principal axis, and principal axis can be found here. So this number here is our principal axis, which is -2. This means that the graph has -2 as our principal axis. Amplitude is 4, that means 2 will be our maximum of the graph, and -6 would be the minimum of our graph. So for period, it's 2 pi over 3. That means for one cycle, okay, it looks like this. So for one cycle, it should be 2 pi over 3. But we only need the graph from -pi over 3 to pi over 3. So from 0 to pi over 3, it would only be the first half of the graph. So let's start drawing from 0. So we have the first half of the graph in this shape. So the right half of the graph looks like this, and for the left half, it should look like this. So we can see that this is the maximum and this is the minimum. For question 2, part A, show that 2x squared plus x minus 15 can be written in this form. So now we need to complete the square, and let me write down the expression. So 2x squared plus x minus 15. So first step, I would factorize the 2 out so that the x squared has a coefficient of 1. And when I factorize the 2 out, I don't have to factorize for -15 because that's not necessary. I'll show you later. So 2 times x plus 1 over 4, which is 1 over 2 divided by 2, and minus 1 over 4 squared is gotten from the previous one here. Close the bracket and minus 15. So I would get 2 times x plus 1 over 4 squared minus 2 times 1 over 16 minus 15. And lastly, we would get 2 times x plus 1 over 4 squared minus 121 over 8. Part B, hence write down the coordinates of the stationary point on the curve. So after completing the square, we can easily find the stationary point using this part over here and this part. So first we take the x plus 1 over 4 and we equate it to 0. So x would be negative 1 over 4. And for y, we just take this part. So we have negative 121 over 8. So the stationary point would just be negative 1 over 4 and negative 121 over 8. Part C, we need to sketch the graph of the modulus of 2x squared plus x minus 15, stating the coordinates of the points where the graph meets the coordinate axis. So we need to find the x and y intercepts. So for y-intercept, we just need to sub x equals to 0. So we would get modulus negative 15, and this would be 15. So for x-intercept, we equate the expression to 0. So y equals 0, and factorize this thing, we get 2x minus 5 and x plus 3 equals to 0. So we have x equals to 5 over 2 and x equals to negative 3. So these are the x-intercepts. Now we can draw a normal quadratic curve. So the stationary point for a normal quadratic graph is negative 1 over 4 and negative 121 over 8. So the graph looks something like this. Something like this. So this is 5 over 2 and this is negative 3, and this would be the stationary point of the normal quadratic graph. Because this is a modulus graph, we need to reflect the part below the x-axis. So we erase the part below the x-axis and we reflect it over the x-axis, like this. Okay, so the new graph should look like this, and the stationary point should be negative 1 over 4 and 121 over 8, positive 121 over 8. And the y-intercept would be a positive 15. And that's it. Part D, we need to write down the value of the constant k for which the equation has 3 distinct solutions. So we have this equation, and another equation of y equals to k. So this means that these two equations intersect with each other, and 3 distinct solutions means that they intersect at 3 different points, 3 intersection points. So when k is a constant, y equals to k is just a horizontal graph. So we have a horizontal graph, maybe something like this. So we need to see where in this graph we can get 3 intersection points. So first we have this part, and you can see that there are only 2 intersection points, so this cannot be the case. When k is 1 to 1 over 8, we can see that there are 3 intersection points, and in this case y equals to 1 to 1 over 8. We know this from the the stationary point here, and this is one of the solutions. Let's see if there are other solutions. When we go further down, we can see that there are 4 intersection points. This 4, so this cannot be the case. And when it reaches x equals 0, there are only 2 intersection points. So this is also not the case. When it goes below x-axis, there are no intersection point. This part of the graph is already erased, so it's no longer here. So we will have no intersection points. So we can see that y equals to 1 to 1 over 8 is the only solution. So we have k equals to 1 to 1 over 8. Question 3 is about solving simultaneous equations. So we have 2 equations. Let's call this 1 and 2. So from equation 2, we have x equals to 1 over 2y. So let's call this equation 3. So we can sub equation 3 into equation 1, and we would have 3y minus 2 times 1 over 2y plus 2 equals to 0. So we can get 3y minus 1 over y plus 2 equals to 0, and times the whole equation by y. So we have 3y squared minus 1 plus 2y equals to 0. We rearrange the equation to get 3y squared plus 2y minus 1 equals to 0. So now we factorize the equation. We have 3y minus 1 and y plus 1 equals to 0. So we have y equals to 1 over 3 and y equals to negative 1. So now we find the x value. So y1 is 1 over 3 and x1 would be 1 over 2 times 1 over 3. So we can get 3 over 2. So this is the first set of solution. So y2 is negative 1 and x2 would be 1 over 2 times negative 1. So we have negative 1 over 2, and this is the second set of solution. For part B, we need to solve the equation of this, giving your answers as powers of 3. So we can see that our log bases are different. One is 3 and one is x, and we need to make them the same base in order to solve them. So to change the log bases, this would be the formula. So if we have log base a b, and let's say we want to change it to log base c, so we would get log base c b divided by log base c a. Alright, so for this equation, let's change it to log base x. So we have log base x over log base x3 plus 3 equals to 10 log base x3. So now log base x is just 1 over log base x3 plus 3 equals to 10 log base x3. So we multiply the equation by log base x3 and we would get 1 minus 3 log base x3 equals to 10 times log base x3 square. The square here is for the whole log and not just for the 3. So we rearrange the equation, we would get something like a quadratic equation. So we can let u equals to log base x3. So we have 1 plus 3u equals to 10u squared. Rearrange it to get 10u squared minus 3u minus 1 equals to 0. So factorize it, we get 5u plus 1 and 2u minus 1. So we would have u equals to negative 1 over 5 and u equals to 1 over 2. So we have log base x3 equals to negative 1 over 5 and log base x3 equals to 1 over 2. So now x to the power of negative 1 over 5 would give us 3 and x would be 3 to the power of negative 5. And the second one, we would have x to the power of 1 over 2 equals to 3 and x would be 3 squared. Question 4. We have a polynomial px equals to ax cubed plus 13x squared plus bx plus c. And it's given that p prime 0 is equal to negative 9. Show that b equals to negative 9. So now we need to differentiate px. So we have p prime x equal to 3ax squared plus 26x plus b. And we know that p prime 0 is equal to negative 9. So we sub x equals to 0 and we have 3a times 0 plus 26 times 0 plus b equal to negative 9. So b is equal to negative 9. And for part B, it's given that 3x plus 2 is a factor of px, and that when px is divided by x plus 1, its remainder is 6. So we need to find the values of a and c. First, we have p negative 2 over 3 will give us 0 because it's the factor of the expression. So we sub x equals to negative 2 over 3, we would get a times negative 2 over 3 cubed plus 13 times negative 2 over 3 squared plus b times negative 2 over 3 plus c. Oops, sorry. For b, we need to change it to negative 9 since we have found it just now. So this is equal to 0. And we would get negative 8 over the 27a plus 52 over 9 plus 6 plus c equals 0. And we can simplify it to c minus 8 over 27a equal to negative 106 over 9. So now we can use this one. So p negative 1 is equal to 6. 6 is our remainder. So we have a times negative 1 cubed plus 13 times negative 1 square minus 9 times negative 1 plus c equals to 6. And this would give us negative a plus 13 plus 9 plus c equal to 6. And we would get c equals to a minus 16. So this would be the first equation, and this would be the second equation. And we can sub the second equation into the first equation. And we would have a minus 16 minus 8 over 27a equals to negative 106 over 9. And 19 over 27a is equal to 38 over 9. So a would be 6. And c would be a minus 16, which is 6 minus 16, and we get a negative 10. So for part C, we can use long division. So we have the equation of px, which is 6x cubed plus 13x squared minus 9x minus 10 divided by 3x plus 2. So we can have 2x squared, and 2x squared times 3x will give us 6x cubed, and 2x squared times 2 equals to 4x squared. So 13x squared minus 4x squared will give us 9x squared. How do I get 2x squared over here? So the goal is to take these two numbers to get, we multiply these two together to get 6x squared. So how do I get this from 3x? Is that I need 2x squared times 3x to get 6x cubed. Right, so we have 9x squared, and we pull down the negative 9x. So to get 9x squared from 3x, I need 3x. So 3x times 3x will give us 9x squared. So 3x times 2 would give me 6x. So negative 9x minus positive 6x would give me negative 15x. So I bring down the minus 10, and How do I get negative 15x from 3x? I would need a negative 5. So negative 5 times 3x would give me negative 15x, and negative 5 times 2 would give me negative 10. So now we know that qx is equal to 2x squared plus 3x minus 5. For part D, we need to find px as a product of linear factors. So linear factors means that the power of x in each of the factor would just be 1. So we have px equal to 3x plus 2 times 2x squared plus 3x minus 5. And this is already linear. So now we need to change this into two linear factors. So we need to factorize it. So 3x plus 2 remains the same. And now we factorize this to get 2x plus 5 and x minus 1. For question 5, a geometric progression is such that the 15th term is equal to 1/8 of the 12th term. So T15 is equals to 1 over 8 of T12. And the sum to infinity is 5. So the sum to infinity is 5. Find the first term and the common ratio. So first we can use this, the fact that T15 is equals to 1 over 8 T12. So T15 would be AR to the power of 14. And this is equals to 1/8 of AR to the power of 11. So A is a constant term, so we can cancel the A out. And R to the power of 14 over R to the power of 11 would give us 1 over 8. And R to the 14 over R to the 11 would give us R cubed. So R cubed is 1 over 8, and R would be 1 over 2. So this is our common ratio. And the sum to infinity would be 5. So A over 1 minus the common ratio, which is 1 over 2, would give us 5. So A over 1 over 2 is 5, and A would be 5 over 2. Part B. Find the least number of terms needed for the sum of the geometric progression to be greater than 4.999. So we have the sum to n is greater than 4.999. So the sum to n is simply just the first term, which is 5 over 2, times 1 minus the common ratio to the n. That means we have 1 over 2 to the power of n over 1 minus the common ratio, which is 1 over 2. So this is larger than 4.999. And we can simplify this to get 5 times 1 minus half to the power of n is more than 4.999. So 1 minus half to the power of n is more than 0.9998. So 1 over 2n would be smaller than 0.0002. And now we can log both sides. So we have log 1 over 2 to the power of n is less than log 0.0002. So we can bring this n to the front. We have n times log half less than log 0.0002. And if we key in log half, we find that this is a negative number. So when negative number is involved, we need to switch this sign. So I'll bring this to the right side, and we will need to switch this sign to a more than. So n would be more than log 0.0002 over log half. And this would be a 12.3 corrected to 3 significant figure. So now we know that n is more than 12.3. So the least number of terms needed for it to be greater than 4.99 should be 13. Question 6. We have the function f(x), and x is all real values. And now we need to find the range of f. So to find the range of an exponential equation, we simply just need to look at the constant value over here. So this would be a -4, and we know that the shape of a e to the power of positive x graph should be something like this. Alright, so this would be the asymptote, and the asymptote is determined by this number. So now the asymptote is equals to -4, and we know that the graph would be more than -4. So the range of f is just larger than -4. For part B, find an expression for f inverse x. So we can switch the x and y. So we have x equals to e to the 3y minus 4. So now we make y as the subject. So we have e to the 3y equals to x plus 4, and 3y will be equals to ln x plus 4, and y will simply just be 1 over 3 ln x plus 4. And we switch y to f inverse x. So we have f inverse x equals to 1 over 3 ln x plus 4. For part C, we need to sketch the graphs of y equals to fx and y equals to f inverse. So we also need to state the exact values of the intercepts with the coordinate axis. So in order to find the x and y intercepts, we just need to, so to find the x-intercept of this equation, this function, we equate it to 0. So we have e to the 3x minus 4 equals to 0. So e to the 3x equals to 4, and 3x would be ln 4, and x would be 1 over 3 ln 4. This would be our x-intercept of the fx graph. And for the y-intercept, we sub x equals to 0. So we have e to the 3 times 0 minus 4. So e to the power of 0 is just 1. So 1 minus 4, we get minus 3. So the y-intercept of the fx graph would be negative 3. So now we can start to sketch our graphs. For the fx graph, we know that we have an asymptote at y equals to negative 4. So let's make this a dotted line so we don't mess it up with the actual graph. Okay, so the graph looks something like this. Something like this. Or maybe I should draw it steeper. Yes, this would be our fx graph. And in order to draw our f inverse graph, we need y equals to x graph. This would be y equals to x. And we need to reflect the graph over the y equals to x line. So the reflection of fx over y equals to x would be something like, okay, first we need to know that now x equals to negative 4 would be our asymptote for f inverse. So same thing, we make it dotted. Okay, now the f inverse graph looks something like, oops, sorry. It's still a bit ugly. Hang on. So we need to make sure that our graphs intersect at these 2 points, this point and this point, and they are reflection of each other over the y equals x graph. This is a bit ugly, but yeah, it's roughly this shape. So this would be our f inverse graph. And for the x and y intercepts, we know that this is a negative 3 and this is 1 over 3 ln 4. And for the f inverse graph, we know that our y-intercept of fx graph would be the x-intercept of the f inverse graph. So this would be a 1 over 3 ln 4, and this would be a negative 3. You can see that this and this are the same, and this and this are the same thing. Question 7 is about integration. So we need to find the exact value of this integration, and we can start. So for cos 3x, we need to change the cos to sine. So we have sine 3x, and for the 3 we need to put it down. So we have sine 3x over 3, and for sine 2x we need to change it to negative cos. So minus 4 cos 2x over 2, and for 1 we just change it to x. So we have this, and now we sub the values in. So we have 1 over 3 sine 3 pi over 2 minus 2 cos pi plus pi over 2 minus 1 over 3 sine 0 plus 2 cos 0 minus 0. And 1 over 3 sine 3 pi over 2 would give us negative 1 over 3. Negative 2 cos pi would give us plus 2 plus pi over 2. Negative 1 over 3 sine 0 would give us 0. And 2 cos 0 would give us 2. So simplifying this, we would get 11 over 3 plus pi over 2. For question 8, we have a diagram with a circle of radius 7. Point A and B lie on the circumference. Line BC is a tangent to the circle at point B, such that the length of BC is 24. The length of the minor arc AB is 12.25. We need to find the obtuse angle AOB, which is this angle. So we know that r theta would give us the arc length, right? So 7 times theta equals to 12.25, and theta would be 1.75. For part B, we need to find the perimeter of the shaded region. So we need, I'll first outline the shape. So we have the arc AB plus this arc plus 7 plus this radius over here. So we know that this radius over here is also 7, and now we need to find what this arc is. The length of this arc. So we know that OBC is a right angle triangle. So we can find this angle over here, BOC. We can find this BOC angle using SOHCAHTOA, because we know that this radius is also 7. So tangent BOC equals to 24 over 7. So the angle BOC is equals to arctangent 24 over 7. And now we can find the arc length. So the arc length would be radius times the angle, which is arctangent 24/7, and this would give us a very long decimal number, but we can write it as 9.009. So the perimeter would be 12.25 plus 9.009 plus 7 plus 7. So 12.25 plus 9.009 plus 7 plus 7. And correct to 3SF, we would get 35.3 meters. Part C. Find the area of the shaded region. So now we need to find the area. It's basically just the area of two sectors adding together. So we have the first sector, this sector. So we have half times r squared times 1.75 plus half times r squared times arctangent 24/7. So we would get 74.4 meters squared, corrected to 3SF. Question 9 is about permutation. So a 6-character password is to be formed from the following characters. No character may be used more than once in any password, so no repetition is allowed. Part A1. Find the number of different 6-character passwords that can be formed. So there are no restrictions, and we have 12 different characters to choose from. So 12p6, because we have 12 characters to choose from, and we need to choose 6 characters from the 12 characters, and the arrangement of the characters matter because it's a password. So we use 12p6, and we would get 665280. Part 2. How many of these 6-character passwords end with a symbol? So now we need the last character to end with a symbol. So we have 6 characters. The last one should be a symbol. So when there's restriction, we will first look at the restriction. Okay? For the last character to end with a symbol, we need to choose from the 4 symbols. So we need to choose one symbol from the 4 symbols. So 4p1 times. So for the first 5 characters, there are no restrictions, and we can choose from letters, numbers, and symbols. But since we already have one symbol here, so we only have 3 more symbols to choose from. So we have 4 letters to choose from, 4 numbers to choose from, and 3 symbols just to choose from. So we have 11 characters to choose from, and we need to choose 5 of them. So 4p1 times 11p5 would give us 221760. Part B. Find the number of different 6-character passwords that include all the symbols but do not start or end with a symbol. So we have 6 characters, and we don't start or end with a symbol. That means the medium, sorry, the middle 4 characters should all be symbols. So now the first and the last characters can end, sorry, the password can start and end only in letters and numbers. So, like what I said just now, when there is a restriction, we start from the restriction first. So we choose 4 symbols from the 4 symbols. So you can either write 4p4 or 4 factorial. I personally would write 4 factorial. It's easier, I guess. So 4 factorial times, so now we have 4 letters and 4 numbers to choose from. So we have 8 characters to choose from, and we need to choose 2 characters. So 8p2, 4 factorial times 8p2 would give us 1344. For question 10, solve this equation. Okay, so we first need to change the range of x. So x would be now 3x plus 1.2, and for the lower bound we need to take 3 times negative 1.5 plus 1.2. So we would get negative 3.3. And for the upper bound, we get 3 times 1.5 plus 1.2. And we would get 5.7. So now we can start solving the equation. So we move the sine and cos to one side, and we get sine 3x plus 1.2 over cos 3x plus 1.2 equals to sec2 over 2. So sine over cos would give us tangent 3x plus 1.2 equals to sec2 over 2, and the base angle would be arctangent sec2 over 2, which is 0.61548. See, I write it to 5 decimal point first because if we now round it to 3SF, it would be inaccurate for our final answer. So we need to round it to around 5SF or 6, the more the better. So now 3x plus 1.2 can be 0.61548, and because it's a tangent, so if this is positive, this will also be positive. Alright, so we have pi plus 0.61548, which is 3.75707, and we also have 3.75707 minus 2 pi, which is negative 2.52612. Why do I minus 2 pi? Because when you minus 2 pi, you basically do something like this. So you turn one round back, and obviously it gives you the same, it's the same thing, right? It's just the value of the angle is different, but the base angle would be the same. So yes. So now we have x equals to negative 0.195, 0.852, and also negative 1.24. All this rounded to 3SF. So why do I not continue here? It's because you see the range here. If I take this and I add 2 pi or minus 2 pi, the answer that I get would be not in this range. For this one, if I add 2 pi, it would be way past 5.7. So if I minus 2 pi, I get negative 2.52612, which is still in this range. So I'm good. And that's it. Question 11, another question about integration. So now we need to find the value of a from this equation. So we first need to integrate this. So we have 3 times ln 3x plus 2 over 3, because of this 3 here, because of this 3 here, minus 2 ln 2x plus 1 over 2, because of this 2 here, and minus ln x equals to ln 1 over 5. So we have ln 3x plus 2 minus ln 2x plus 1 minus ln x equals to ln 1 over 5. So we sub the a and 1 into this expression, and we would get ln 3a plus 2 minus ln 2a plus 1 minus ln a minus ln 3 plus 2 plus ln 2 plus 1 plus ln 1 equals to ln 1 over 5. And now we have ln 3a plus 2 minus ln 2a plus 1 minus ln a minus ln 5 plus ln 3. Ln 1 is 0, so we can ignore that, equals to ln 1 over 5. And now we can group. We group this at the left side, and we group this on the right side. Separate the a's and the constant terms. So we have ln 3a plus 2 minus ln 2a plus 1 minus ln a equals to ln 1 over 5 plus ln 5 minus ln 3. And we know that we can actually group them into one ln, right? So we have this minus this, which means we have ln 3a plus 2 over 2a plus 1, because of this minus, right? And for ln a is also a minus, so it's also being divided. So this is what we will get on the left side. And for the right side, we have ln 1 over 5 times 5 over 3. And this would give us, so ln 3a plus 2 over a times 2a plus 1 would give us ln 1 over 3. And now we can cancel the ln off. So we have 3a plus 2 over a times 2a plus 1 equals to 1 over 3. And we cross multiply it, we would get 9a plus 6 equals to 2a squared plus 8. Rearrange it to get 2a squared minus 8a minus 6 equals to 0. And we have a squared minus 4a minus 3 to make our lives easier. And now we can use the quadratic equation. Now we have a quadratic equation. We can use the formula to find for a. So we have a equals to minus negative 4 plus minus negative 4 squared minus 4 times 1 times negative 3. Square the whole thing over 2 times 1. And this would give us 4 plus minus 2 third 7 over 2, which is 2 plus minus third 7. And if we look back at the question, it says that a is larger than 1. So the final answer should be 2 plus third 7. Because 2 minus third 7 is lesser than 1, and we should reject it. Question 12. We have this equation, and for part A, we need to differentiate it to get our answers in this form. So you have dy over dx is equal to x minus 1 times 2 over 3. So we move this power down here. So we get 2 over 3 times 3x squared minus 2. And 2 over 3 minus 1 would give us negative 1 over 3 times, and we differentiate this thing inside here to get 6x minus this thing over here, which is 3x squared minus 2 to the power of 2 over 3. And we differentiate this thing over here, which is just 1 over x minus 1 squared. So we just square our denominator. And now we can simplify it. We can factorize this out. So 3x squared minus 2 to the power of negative 1 over 3. And we are left with 4x times x minus 1 minus 3x squared minus 2 over x minus 1 squared. So we have 3x squared minus 2 to the power of negative 1 over 3 over x minus 1 squared times 4x squared minus 4x minus 3x squared plus 2. So we would get 3x squared minus 2 to the power of negative 1 over 3 over x minus 1 squared times x squared minus 4x plus 2, which is exactly the format that they want. For part B, we need to find the approximate increase in y as x increases from 2 to 2 plus p. So now we should first find what dy dx is when x equals to 2. So when x equals to 2, dy over dx would be, so we sub x equals to 2 into this expression over here, and we would get 3 times 2 squared minus 2 to the power of negative 1 over 3 over 2 minus 1 squared times 2 squared minus 4 times 2 plus 2. And this would give us negative 2 over cube root 10. So the approximate increase in y over the approximate increase in x is about the value of dy over dx. So this is around negative 2 over cube root of 10. And since the approximate increase in x is p, you see that it's increased from 2 to 2 plus p. That means p is the approximate increase in x. So we have the approximate increase in y over p is approximately negative 2 over cube root of 10. So approximate increase in y is around negative 2 over cube root of 10 times p. For question 13, we have the points P and Q with these two coordinates, and point R lies on the line L, which is the perpendicular bisector of the line PQ. The x-coordinate of R is 7. So we have a line, this would be P, and this would be Q. So we have a perpendicular bisector over here. Perpendicular bisector means it bisects the line, it cuts the line into half, and this is 90 degrees. So R would be here. So P is 5, negative 12, and Q is 15, negative 6. R is 7, and we need to find the y coordinate. How do we do that? We know that this is the midpoint of PQ. Let's call it M. And now we need to find the coordinates of M. So M would be 5 plus 15 over 2, and 12 plus negative 6 over 2. So this would give us 10 and negative 9. So M would be 10 and negative 9. So now we can find the gradient of this line over here. So the gradient of the line PQ would be negative 12 minus negative 6 over 5 minus 15, which is 3 over 5. And the gradient of line L would be negative 5 over 3, because when they are perpendicular to each other, the MPQ times M of line L would be -1. So when 3 over 5 times this gradient, we will get -1, and this gradient is simply just -1 divided by 3 over 5. So we get -5 over 3. Okay? So now we have the gradient and a point on the line L, and we can find for the equation of line L. So we have y minus 9 equals to -5 over 3 times x minus 10. So y would be equal to -5 over 3x plus 23 over 3. This would be the equation of line L. So let's write down the equation of line L would be this. And to find for the y coordinate of r, we just sub x equals to 7. So -5 over 3 times 7 plus 23 over 3 would give us -4. For part B, the point S lies on L such that its distance from PQ is 3 times the distance of R from PQ. So let me copy this diagram. So this line here S is 3 times the distance of R from PQ. So the distance of R from PQ is simply just the distance Rm, because the shortest distance of a point to a line is just the perpendicular distance from the point to the line. So distance R from PQ is just distance Rm, and S can either be here or here. So okay, distance of S is equals to 3 times the distance of R, and distance of R is just distance of Rm, which is 7 minus 10 squared plus -4 minus 9 squared. Square the whole thing, and we would get sub 34. So now ds is equals to 3 sub 34, and distance of S from PQ is the distance SM. So now we can write S as X and Y, but since we know that the equation of line R is given as this, so we can write S as X and -5 over 3x plus 23 over 3. So the distance S from PQ can be written as x minus 10 squared plus -5 over 3x plus 23 over 3 minus 9. Square the whole thing, and this is equals to 3 sub 34. So let's simplify this equation. We would have x squared minus 20x plus 100 plus negative 5 over 3x plus 50 over 3 squared equals to 9 times 34. So I square root both sides to get rid of the square root function to reduce our mistake. So we have x squared minus 20x plus 100 plus 25 over 9x squared minus 500 over 9x plus 2500 over 9 equals to 306. And after simplifying it, we would get 34 over 9 x squared minus 680 over 9x plus 646 over 9 equals to 0. And we can divide the whole equation by 34 over 9. And we would just get x squared minus 20x plus 19 equals to 0. This is the continuation, yeah? So we can factorize it to get x minus 19 and x minus 1 equals to 0. So x would be 19 and x would be 1. So when x is 19, y would be negative 5 over 3 times 19 plus 23 over 3, which is negative 24. And when x is equal to 1, y can be negative 5 over 3 times 1 plus 23 over 3, and this would give us 6. So s can be 19 and negative 24, or 1, 6. These are the two possible coordinates of s. And we're done.